minus 4x minus 20 equals 0. I will tell you we are able to factor this. If we factor this, we're going to get a 3x minus 10, and then we'll get an x plus 2. So when we solve, we set each factor equal to 0, and we'll get x equals 10/3, and we'll get x equals -2. And going back to the original problem, do we agree that A was 3, B was -4, and C is -20 if we're looking at it as ax squared plus bx plus c? So A is 3, B is -4, C is -20. What I want us to do is I want us to add the two roots. So if I add the two roots, do you all agree I am adding 10/3 plus a -2? In order to add these, we need a common denominator. So I'm going to have 10/3 plus -6/3, which is going to give us positive 4/3. If I'm looking at this, positive 4/3, well, isn't that denominator A? A is 3. And my numerator is 4, but B is -4. So wouldn't the numerator be the negation of B or the opposite of B if B is 4, if B is -4 and this is a positive 4? So this looks like it's the equivalent to -b/a. Now what I want us to do is multiply the two roots. So that means I'm going to take 10/3 and I'm going to multiply it by -2/1. And when we multiply it, we end up with a -20/3. Well, what is that in terms of A, B, and C? Charlie? C over A. This is C over A. Guys, this is not a coincidence. Anytime you add the two roots together, it will always be -b/a. Anytime you multiply the two roots together, it will always be C over A. Do you guys want to see where this comes from, or you don't really care? Charlie, you want to see? Okay, let's show you. So let's say we have ax squared plus bx plus c equals 0. Do we all agree the first root will be, if we're using the quadratic, -b plus the square root of b squared minus 4ac all over 2a. And the second root is going to be -b minus the square root of b squared minus 4ac all over 2a. Yes? Okay, so let's keep going here. So now let's go now and add these two roots together. So this is my root 1, this is my root 2. So now I want to add root 1 plus root 2. So when I add it together, because they have the same denominator, I keep my denominator, and can I just add the numerators together? But when I go to add the numerators together, I have a -b plus a -b, which is a -2b, but then I have a positive root b squared minus 4ac, and I have a negative root b squared minus 4ac. So what happens there? They cancel. So actually, I'm just left with -2b over 2a. Can I cancel out those 2's? So then root 1 plus root 2 will be -b over a. And that's the sum of the two roots. Now I'll show you the product. So now if we take root 1 times root 2, So back up. We're going to multiply them. So in my denominator, 2a times 2a, isn't that a 4a squared? And now what do I have to do with the numerator since they're binomials? FOIL, exactly. So we're going to have a negative b times a negative b is a positive b squared. Then I'm going to have a positive square root of something times, so negative b times a negative square root of b squared minus 4ac gives me a positive b times the square root of b squared minus 4ac. Now we have a positive root b squared minus 4ac times a negative b, which gives us a negative b root b squared minus 4ac. And then I have this times this. Well, isn't it the same exact radical? So don't the square roots cancel each other? So we're going to have the negation of parentheses b squared minus 4ac. Are those parentheses important there? Yeah, because I'm subtracting that whole quantity. So now the middle terms cancel as they should because it's a dots. And now I'm going to be left with my numerator, which is b squared. And now I'm going to distribute in this negative minus b squared plus 4ac all over 4a squared. Now the b squareds cancel. And then I'm going to be left with 4ac over 4a squared. Well, the 4's cancel. And if I divide a to the first divided by a to the second, I end up with an a in the denominator. And that gives us the product of the roots. Just for fun, in case you cared. Okay, so let's sum it up. The sum of the roots so root 1 plus root 2 will always be negative b over a. And the product of the roots which is root 1 times root 2, will always be c over a. And this is assuming a cannot be what? 0, right? A can never be 0 because that will be undefined there. Okay, so how would we use something like this? Let's jump right into an example. I want us to write a quadratic equation that has roots and the first one is going to be root 1 is negative 5/4 and root 2 is 16 over 5. Okay, well, when I ask for a quadratic equation, this part right here, it means I need something in the form of ax squared plus bx plus c. But now since I'm asking not for a quadratic function or a quadratic expression, I'm saying give me a quadratic equation. What do I have to do? What do I have to have in this to make it an equation? Lily? Yep, so we're going to say equals 0 to make it a quadratic equation. Now, if you guys remember, I now just need a number. I need values for a, b, and c. And once I get values for a, b, and c, then this quadratic equation will make sense. So we said root 1 plus root 2 ends up giving us negative b over a. So that could get me an a and a b. And then root 1 times root 2 gives us c over a. So that could give me a c and an a. So let's go through this. Root 1 plus root 2. So I have negative 5 over 4 plus 16 over 5. In order to add these, what must I create? A common denominator. So I'm going to create a common denominator of 20. So I end up with a negative 25 over 20 plus a 64 over 20, which ends up giving us a positive 39 over 20. And this represents negative b over a. Now I'm going to do the same thing for the product of the roots. So I have negative 5/4 times 16 over 5. When we're multiplying, can I cross simplify? Yeah, we can cross simplify, but I'm choosing not to. Does anybody know why I'm choosing not to? Charlie?
So you don't get rid of the fractional form?
Yeah, well, yes and no. Let's say I did cross simplify. Let's just do it that way. Let's say 4 goes into 16 4 times, and then I could say 5 goes into 5 1 time. Do we agree? So now we're going to multiply across. I'm going to have negative 1 times 4 is a negative 4, and then 1 times 1 is 1. So this would tell me C over A, but there's a problem there. Because in the first sum of the roots, aren't I saying A is 20? But now in the product of the roots, I'm saying A is 1. Can I have two different values for A? No, I have to make my A's the same. So what would I have to do here to make the A's the same? Multiply top and bottom by 20 if I'm going to use the negative 4 over 1. Or I could have just gone back from the beginning, right? And realized I need that denominator of 20. Why do I need that denominator of 20? To make the A's the same. So if I'm keep making my denominator 20, I can just multiply across. So now I'm going to have negative 5 times 16, which is a negative 80. If we had stuck with the negative 4 over 1, couldn't I have just multiplied top and bottom by 20 and still gotten that negative 80 over 20? Would it have worked? Yeah, you would just realize later on that, oh man, I got to create that common denominator so I have both A's being the same. Does that make sense? Okay, so now this represents C over A. Why am I not reducing this? Because I can reduce negative 80 over 20, and up until this point, we've always reduced our fractions. Ali?
Because you want A to be the same.
Because the A's have to be the same. So I cannot reduce this. So what does this tell me? This tells me my A is 20. Our B is, well, if negative B is 39, what's positive B? Negative 39. And C is negative 80. So our quadratic equation is going to be 20x squared minus 39x minus 80 equals 0. And that's how we use sum and product to get us that quadratic equation. How else could I have gotten this quadratic equation if I didn't know sum and product? Charlie?
You have like made X equal each of those products and then like oiled them.
Yeah, we could have set, so the root 1 was 5/4, negative 5/4, and root 2 was 16 over 5. We could have set them each equal to X and worked backwards to get our factors. Now, if I'm going to get my factors, would it just be X plus 5 over 4? No, what was I saying last class? What do we have to do? The step-by-step inverse, right? So we're going to first multiply by 4, which gives us 4x equals -5. Then I'm going to add that 5 over. So 4x plus 5 is one factor. And then for this one, we could have multiplied by 5. And we would have gotten 5x equals 16. So then the other factor would be 5x minus 16. Now that I have the two factors, now what would I tell you to do? FOIL. That was the other way to do this. All right, ready for another one? So that was A, say B. Let's say root 1 is 5 plus 2i, and root 2 is 5 minus 2i. And again, I'm looking for the quadratic equation that gave me these two roots. I'm going to use sum and product. So we need ax squared plus bx plus c equals 0. That's what we're looking for, a quadratic equation. So I need a value for a value for b, a value for c. Well, we know root 1 plus root 2 gives us negative b over a. And we know root 1 times root 2 gives us the c over a. So I'm going to use those two formulas. So if I have 5 plus 2i plus 5 minus 2i, I have a plus 2i and a minus 2i. What happens there? They cancel. So I'm left with 5 plus 5, which is 10. Do we agree this is a 10 over 1? And that's going to represent negative b over a. Now I'm going to multiply root 1 times root 2. So I have a 5 plus 2i and then a 5 minus 2i. Who remembers when you have an a plus bi times an a minus bi, what do you end up getting when you multiply complex dots? It doesn't end up being a squared minus b squared. It ends up being a squared plus b squared. Do you all remember that from last chapter? So my a is 5. So I have 5 squared plus my b squared. My b is 2. My b is not 2i. The b is the coefficient of I. So that's a 2 squared. So then we have 25 plus 4 is 29 over 1, which represents c over a. So now before I create my quadratic equation, I have to make sure of something. What do I have to make sure of? Looking at the two fractions. Ariana? That the a's are the same. Are my a's the same? Yes. All right. So what would you do if the a's aren't the same? What would we do if the a's weren't the same? Charlie?
You would like find a common multiple and multiply.
Yeah, you would make them the same. You would create a common denominator between them to make them the same. So now we're going to write out ax squared plus bx plus c equals 0. So our a is 1. Now negative b is 10. If negative b is 10, what's positive b? Negative 10 plus c is 29. And there is our quadratic equation. Okay, I want you guys to try this one. So the first root is 6 plus I root 3. And the second root is 6 minus I root 3. All right, who thinks they have an equation for me? Amanda?
X squared minus 12.
Perfect, equals 0. If I ask for an equation, do you have to put the equal 0? Yes, on the test, if I ask for an equation and you do not put the equal 0, that would be a -1. So you want to be very cautious of that. Anybody want to see me do this? All right, one more problem, then we're done. So I want us to find K such that -3 is a root of x squared plus kx minus 24 equals 0. So for this one, do we agree our A is 1, our B is K, which is what we want to find, and our C is -24? Yes, we agree? All right. Do we also agree root 1 is -3 and root 2, is it a question mark? We don't know what the other root is. Okay, so if I have C, I don't know B, but I do know C. So I'm going to work with C first. I know root 1 times root 2 is equal to C over A. Well, I know root 1 is -3. Root 2 is still a question mark. We don't know. I know that C is -24, and I know A is 1. Can I solve for the second root using this? Absolutely. How is that going to help me find K? So I'm able to solve this for the second root, and now I'm going to use it to help me find K. How will that help me find K if I know what the second root is? One person, 2 people, 3 people, 4 people. Anushka? Good. Then we could add the 2 roots, and we know that's -b over a, so that will help us find what b is. So we're going to now solve this. I have -3 times our second root equals -24. So I divide by -3 on both sides. And then we end up with our second root being -24 divided by -3, which is 8. This helps us tremendously because now I know root 1 plus root 2 is equal to -b over a. So -3 plus a +8 has to equal -b over a. So we have, +5 is going to equal -b over a. But what did we know a was? 1. So what does that tell us? -b is +5. So positive b is -5. So find K. K has to equal -5. All right. We are done for today. I'm not going to assign any homework. We're just going to use the sum and product idea in tomorrow's lesson. So that's where we're going to stop.